Hmm. So for you, it is less than her.
Okay.
Okay. So you have map, filter, union, group by, reduce by, join. This is for RDD. And data
Mm.
frame or data set, you have that many of functions. You have very less function in Scala. In Python, it is too big. Here it is 48 function for PySpark. Sorry, for data frame. And here it is like 30 for unit, not even 10. So, look, theoretically, an example, whatever I will give you, that will be the very simple. Okay.
Mm.
But in production level, you cannot able to do the simple things, no? That is
Correct,
that.
correct. Mm.
So, like, that is the reason I want to give. So, so some of the transformation, it should be like production level, just like
Mm.
using window function, or
Mm.
I'm telling, I told you, I guess, I was stuck in one transformation in my last company. That
Okay.
was like for because my last company deal with GST. Okay,
Mm.
so one of the five company in India who are
Mm.
manipulating or creating GST rates. Okay.
Mm. Okay.
So, and we are providing, actually, my last company is government company,
Mm.
and we are providing API. So everywhere you can, clear tax. You heard
Mm.
about this one.
Yes. Yes.
They are
Yes.
using our API.
Oh, okay.
All big company like Walmart,
Mm.
uh,
Mm.
Amazon. Next one is that. TCS, not TCS, Genpact is there,
Mm.
Dell is there, all those company using our API. Okay,
Okay.
so there was, we faced one problem. So while doing the duplicate checking, okay, this is the very important thing to duplicate check in transformation. Okay,
Mm.
so that depends on four category. One is document date. GST means invoice number. Okay,
Mm. Yes. Yes. Okay.
so GS, document date, that is invoice date, invoice type, either it is credit note, either it is debit note, or it is normal invoice. Okay, lot of things is there. That one, HSN code, and value. These
Mm.
four is our this one, but it's a duplicate category. Okay, if
Mm.
so, you they are sending like GB of record, GB. Sometimes it
Mm.
is
Mm.
TB. So it may happen it create duplicate, and it is normal.
Mm.
Okay, so if it is 10 GB, then you have to understand 1 GB will be the duplicate record.
Okay.
Okay, so while doing the figure it out, because we did very simple code. Okay, at the very first, it happened on
Mm.
2021. Okay, when
Okay.
GST is the new in India.
Mm. Mm. Mm.
So what happened, we, because one invoice have multiple items.
Mm.
So if you go to a restaurant, okay, they will give you one bill, and in one bill they have multiple items, and every multiple
Mm.
items has their own price. Okay,
Mm.
now what happened? Price is different. So now
Mm.
when they are sending CSV file, okay, there will be, suppose you have four item. Okay,
Mm.
in four item, there will be four row, because their invoice
Mm.
is same, document date
Mm.
is same, HSN code is same. Okay,
Mm.
but item is different. That's why
Mm.
it's create four row. And
Mm.
we did very wrong, and we removed last three and took the first one only.
Okay. Okay.
Okay, so in 2021, we got like 3,000 escalation
Mm. Mm.
because of we removed their number, no? So that
Mm.
create a mess in government portal. Government
Mm.
sue us. We find around 10 crore rupees.
Mm.
Okay, this happened. So
Mm.
this type of production thing you have to learn. So how you can tackle this type of things? How you
Mm.
so if what we did, if the price is changed and HSN code is changed, then the duplicate
Mm.
will not happen. It will uh, merge the document price and create one whole document price instead of every single item price. This is how we did that.
Okay.
So
Okay.
this type of production thing, because what in this case you can see, what I will tell you, how filter work, how
Mm.
with column work,
Mm.
how drop, group by, order by. these are the functions, but the problem
Yes.
is,
Hmm.
you have to implement it in properly,
Correct.
production level,
Correct.
these things, no?
Hmm. Hmm.
So without testing, that will be the very difficult. Okay, tell me, last day I told you what we should start from.
Yeah, yeah. I pinged today. I think you're going to start that SQL engine, Catalyst Optimizer, RDD, DAG, job, stage, and task.
Um, the image. 1 second. So look, today's theory is very important. Whatever you learn, it's okay, but yeah, architecture is a big thing, and
Hmm.
SQL engine is a very big thing. Okay,
Hmm.
the whole heart of Spark is depend on SQL engine. Okay,
Okay.
so your code, the optimization, because why we are choosing PySpark, yeah, instead of Hadoop, because of that optimization. Okay,
Hmm.
and you can understand Catalyst optimizer. So
Hmm.
your total optimization depend on Catalyst optimizer. Okay, so you need to learn a lot about these things. Whenever
Okay.
you are going to work anything, you have to keep in your mind how your Catalyst optimizer responds.
Okay.
A single line code you have to write. Before that, you have to keep in your mind, okay, my cluster is, so cluster management I will tell you later, okay,
Hmm.
tomorrow. But
Hmm.
you have to, this is the response, and what is, look what we are doing, okay, production level, I'm telling you what we are doing.
Hmm.
So every single day, my because I am working on a project which is named Santander. Santander is the Europe, whole Europe, okay, except Britain, okay,
Hmm.
whole Europe banks data, because all
Okay.
bank are using Santander. Okay, now whole think about how much data daily they are producing. Okay,
Okay.
they are not
Yes.
using UPI. They are
Hmm.
they are everything dependent credit card.
Hmm.
Okay, even they are not using debit card also. They are
Hmm.
maximum when 99% credit card, 1% another transaction, check transaction and all. Okay, so
Okay.
think about it, how much data regularly, how much data we are generating here.
Hmm.
So now I'm telling you as an example, I cannot tell as a whole thing.
Hmm.
Suppose I have three cluster.
Okay.
Actually, I have total 1023 cluster. Now 27 cluster. Now as an example, I'm telling you I have three cluster. Okay.
Okay.
1% that is mapping with Germany, this type of South
Hmm.
Europe.
Hmm.
Okay. One
Hmm.
is Middle Europe and another is in North Europe. That is Switzerland, France, those type of, sorry, Switzerland, Zurich, these type of things. Okay.
Okay.
So now you have three server. That means three cluster. I'm not telling you
Hmm.
server. I have three cluster. Okay, in cluster, suppose I have 40 machines and number of
Okay.
machines is 10.
Hmm.
Okay, now you understand, if I have a 40 machine and every machine have 100 GB RAM. Okay,
Hmm.
that means 4000 GB RAM per each machine,
Hmm.
and you have 40 machine like that. That much of RAM you have. Okay,
Hmm.
now you are using petabyte of data. Later you will
Okay.
know, when you uh, run this code, no, you need to know how much my executor will work simultaneously.
Okay.
Okay, and my what it say, one executor or another is like driver, how much
Hmm.
driver data can we, because look, later you will understand, before driver, no, think about
Hmm.
this architecture. One
Hmm.
is driver, another is like worker. Okay,
Hmm.
so there I show you only one driver. Okay, that
Hmm.
can be
Yes.
multiple driver there. Okay,
Hmm.
so
Okay.
each driver memory, each executor
Hmm.
memory,
Yes.
okay, that can maximum process 2 petabyte of data. Suppose
Okay.
now
Hmm.
in this time in December, okay, uh, in Christmas Eve. Okay, they are using credit card more because they are shopping a lot. Okay, Christmas for Christmas
Hmm.
tree,
Hmm.
blah 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 blah. Now
Hmm.
your data is 6 petabyte per day.
Hmm.
Normally your structure is 2 petabyte, and now you are getting 6 petabyte. Okay,
Hmm.
but you don't have money in your pocket to extend your cluster.
Okay.
Okay, now how you will do that? How much partition is required? Okay, I'm coming to this position. Now
Hmm.
your
Hmm.
CEO telling you, Sagar, I need optimization. Do whatever you want,
Got it. Hmm.
whatever you want. I need optimization. I cannot give you any resources.
Okay.
So
Hmm.
whatever resources you have, play with it only.
Hmm. Hmm.
So
Got
what
it.
you will do
Hmm.
first of all, you will check, okay, one partition, one partition of data or one executor, how much
Hmm.
time data they are taking. Okay, one chunk of data, suppose 2 MB data, one chunk that is mean 2 MB data, 200 MB data, 200 MB data, how much process time it is taking. Okay, so your
Hmm.
if it is taking 0.01 millisecond, okay, then you have to reduce it microsecond. How you will do it? You will do after sending to 200 MB.
Hmm.
Okay, don't
Hmm.
force any data. When you are forcing something, no, to enter this one, it will create a mess. So you will
Okay.
put a starter sleeper there
Okay.
to enter those data. Those things you have to do runtime. No one is going to say you because your CEO, your manager will tell, Sagar, this is the data we are getting. We are facing this problem. Now you have to solve.
Hmm.
No
Hmm.
one is going
Okay.
to give you any suggestion there. So then you have to think how much my catalyst optimizer will can execute or can process. Okay, how much my physical memory can process, how my logical
Hmm.
memory can process. With calculating all those things, you have to write your code. So somewhere you have to write filter, somewhere you have to write where
Okay.
is more
Hmm.
dependable, but it is taking time. So you
Hmm.
have to
Hmm.
shift from where to filter,
Okay.
where you have
Hmm.
to write normal SQL code, where you have to write a normal your Scala code. That
Okay.
only you in your what you have you what you know, that is your
Hmm.
catalyst optimizer.
Okay. Okay. Got it. Hmm.
Only we depend on this one, you have to figure it out how you will do that. Okay, so you can send data uh, to executor, okay, in various form. So you
Hmm.
can send data query, SQL query, or you can send data frame, or you can send via data set. Okay, after getting data, okay, you are creating this type of thing either from SQL query or from data frame or data uh, set. Okay, now 1 second. Okay, so SQL engine, data frame or data set, that means when you are doing any transformation or action, okay, you will
Hmm.
write SQL query, data frame. Last day I will tell you what is the transformation action. Remember?
Hmm. Yes. Yes. I recall.
So you are doing like that. Okay,
Hmm.
so after doing what SQL engine will do, SQL engine will do, suppose let's take with SQL query. Okay, data frame
Hmm.
will do later. Same thing for data set, data
Hmm.
frame
Hmm.
also. Let's, for easy to understand, we'll go with the SQL query. We are sending SQL query there. Okay. So after getting that SQL query, okay, what Spark engine will do, Spark engine will read that SQL query. Okay. And check the SQL query syntax is okay or not.
Hmm.
Okay, think about it. Listen to me very carefully.
Hmm.
Unresolved logical plan, from SQL query to unresolved logical plan. That means it is checking only syntax. Okay,
Hmm.
nothing more than that. If syntax is okay or not. Okay, then put
Hmm.
after end semicolon is there or not.
Hmm.
That
Okay.
means only syntax it is checking.
Hmm.
If it is pass, okay,
Hmm.
if it is pass, then it checks with catalog. So what catalog is? Catalog is nothing but, so whenever you create a table or data frame, or data set, okay, every time you will create a metadata of that
Mm,
table, of that data frame, of that data set. Okay, so
okay.
what metadata contains? Metadata contains nothing but the outer structure of the database, of the table.
Mm,
Okay, so it will not deal with what record you put in this table. The metadata everywhere. Later you go for any other things. Okay, you in
mm,
SQL also. Metadata, what is metadata means? Metadata means nothing but the outer plan of that one. That means
mm,
what is the database name? What is the size? Okay, who makes it? Okay, how many record you have? This type of outer things maintained by catalog, the metadata.
mm,
Okay, and catalog contain all the metadata. So suppose you are using 30 data frame, okay, or 15 data, yeah, or MySQL in table you have a record, okay, so and it contain 1 lakh, uh, sorry, it contain 100 table. So for all tables, metadata will store into catalog.
okay.
Okay. So now your unresolved logical query, which is only checked by unresolved logical plan, which is correct with syntax and comma, a semicolon, this type of things. Okay.
Mm,
It will check the phase is four phase. One is analysis phase, one is logical optimization phase, one is physical planning, and last is code generation. So in
mm,
analysis phase, your logical unresolved logical plan with checking meta catalog, which is storing metadata. Okay, do the analysis. That means, okay, you are asking for one table. Select asterisk from employee table. Okay, if the
mm,
employee table exists, their metadata should be there in catalog.
okay. Mm,
Now you are
okay.
dealing with employees designation. There
Mm,
also it will check in catalog table, is there any column of designation? Okay, that those analysis thing happened here.
mm,
Okay, so it is there or not. Okay, that column is there or not. Everything check in the analysis phase with help of catalog.
okay.
Okay, so
Mm,
now obviously, and one more thing, only table existed, not the table existed, even data type. So you are sending one table, okay, you are storing data into table, okay, with SQL query. But the problem is in date field, your table it is in date column, okay, but you are
mm,
sending the integer column. That means you are mismatching that data type.
mm,
In that particular case, analysis using the catalog will check and you will give the error. No, you cannot do that. Okay, that means your logic in syntax, listen carefully again. In syntax, you are solving your unresolved logical plan. When unresolved
mm,
logical plan will complete, you are going to use catalog and in analysis phase. If
mm,
everything is okay, that means if table exists, if column exists, if data type is proper, okay, it will check function is available or not, because in Spark you are going to write a lot of function. Even in
mm,
MySQL
mm,
also you are going to lot create. So function is allowed for that or not. Okay, all those
mm,
stuff it will check in analysis phase. If everything is okay, it will comes into logical plan.
okay.
Okay,
Mm,
now you are getting uh, logical plan, you are getting the query, okay, or data frame, any data frame query also. Okay, now in logical plan, uh, you are going to encounter logical second phase, which is called logical optimization. There you have to do, okay, write down these things
okay.
first. Predicate push down,
One minute. Yeah, what?
predicate,
We are
edicate,
predicate.
push down.
Okay,
If you are a data engineer, all those stuff is your bible. Okay,
okay,
constant folding,
Okay.
projection pruning,
Okay.
filter reordering,
Okay.
okay, and simplification.
Okay.
Okay, so after coming logical plan, okay, and the your state will be logical optimization. First, it will check predicate push down. Okay, what is predicate push down? Predicate push down is nothing but, so suppose you can do one thing, select asterisk from your table. You are getting
Hmm.
data, then you can do filter.
Hmm.
Okay, so you are getting whole data, you are reading whole chunk of data, then you are doing the filter. Think about it,
Okay.
how small thing will increase the optimization.
Hmm.
Instead of, if I read the data with using that condition, select asterisk from table where this one.
Hmm.
So it will read only those type of data. It will not going to read, because data is splitting into multiple partition. Okay,
Hmm.
and partition contain the metadata.
Hmm.
Now, when you put where this one equal to that one,
Hmm.
okay, it will check only that particular partition instead of the whole table.
Yes. Hmm.
Then think about, you have terabyte of table. Your
Hmm.
table stored terabyte of data. Okay, like 100 terabyte. Now
Okay.
you are selecting all the column. You are asking all the column. In second line, you are doing the filter.
Hmm.
Think about how much time it will take. Instead of, if you do, because as I told you, data are splitting into partition and storing into as an like uh, distributed manner. Okay, that is why we are using Apache. Data is distributing, data stayed in distribution manner. So there you are easily going to crack that record and
Hmm.
uh, fetch that record. So
Hmm.
it
Yes.
it is like thousand time, actually the thousand time faster than the previous one concept.
Hmm. Yes.
Okay, so this is called predicate push down. That means you are asking uh, what it say condition you are putting while reading the data.
Hmm. Got it. Hmm.
Okay, my screen is visible, no?
No, no.
Predicate push down.
Hmm.
Predicate push down is the query optimization technique that apply filter condition as early as possible in the query execution pipeline.
Hmm.
Okay, ideally at the data source. That means you are sending your condition in the data source while fetching the
Hmm.
data. You are not uh, asking coming all the data, then you are doing the fetch thing.
Filtering. Hmm. Got it.
Okay, this is the predicate push down, nothing but
Hmm.
filtering at the sources using metadata. Okay, select a strings of table name, column equal to value. Predicate
Hmm.
push down would tell the data source only send me those rows where column equal to value.
Hmm.
Okay, it is uh, the core feature of the Apache Spark and Amazon Athena. In Athena, you are every second you have to use that one only. Otherwise, you will die down. Okay,
Okay.
partition. It is
Hmm.
partitioning is there, so easily you will get that one. Okay,
Hmm.
so this is what predicate push down is.
Hmm. Okay.
Okay, next is constant folding. Okay, constant folding is nothing but, look, you can do one thing. Uh, no, better. Let me tell you this. This is also query optimization technique where Catalyst Optimizer evaluates expression containing only constant value at compile time instead of run time. Okay, you don't understand, I guess.
Hmm. Hmm.
Constant folding in Spark is a very query optimization. Okay, who did that? Catalyst Optimizer. Okay,
Okay.
this logical plug. This is
Hmm.
Catalyst Optimization. Logical optimization. Who did that one? Catalyst Optimizer did.
Okay.
Okay, so where the catalyst optimizer evaluate expression containing only constant values at compile time instead of runtime. This reduces the computation needed during execution, making queries
Okay,
faster
okay,
and
got
more
it.
efficient. For example, Spark will replace an expression select hello plus world with hello world during the planning phase. Okay, so it is
Hmm.
nothing but look here with column money you are adding one column which is effective
Okay.
salary. Okay, you don't have that
Hmm.
one effective salary into column
Hmm.
blah
Hmm.
blah blah blah. Okay,
Okay. Hmm.
so if you do these things into runtime, okay,
Hmm.
the whole execution while doing this one, whole execution will create a lot of time. Okay, instead of that,
Yes.
because your action is explained.
Hmm.
Okay, so instead of DF optimization, if you create like this one, this one dot explain, okay, extended equal to true. Same thing in Scala also. Okay, extended equal to true.
Hmm.
Okay, so this is not a constant folding. Constant folding means in runtime you are doing the calculation and the runtime you are doing the explaining. Got my point?
Compile, right? Hmm.
No, here you are doing it in runtime only because you are
So,
asking for explain. No, end of the day it will check explain.
okay, it's
Explain,
a action.
sorry, action.
Is this a action that you are
This
telling?
is action. Explain is action. So
Action.
I told
Okay.
you,
Okay.
description, describe,
Hmm.
show,
Hmm. Hmm.
explain. Those are the action.
Hmm. Hmm. Okay. Okay.
So act
Hmm.
that means it is a runtime. Action means runtime.
Hmm. Hmm. Yes. Yes.
Now think about it. When he encounter this explain, it will
Hmm.
understand. Okay, explain means I have to do the runtime things.
Hmm.
So in
Correct. Hmm.
runtime, it will do this calculation and explain also.
Hmm.
Okay. Now when you are dealing with petabyte of data, confirmly your code will hang
Hmm. Yes.
because you are giving so much pressure at the time at the runtime.
Hmm.
Instead of that, okay, split it. DF example. Okay. So this one read by compile time.
Hmm. Okay. Got. Huh.
Okay. And this one only do by runtime.
Hmm.
Got my point?
Yes.
Instead of feeding everything at once at the runtime, do
Hmm.
it in a compile time and rest of the thing do it in runtime.
Hmm.
It will not give a pressure to your code.
Correct. Line one runs only when it is compiling. The
Yeah,
line two will run during runtime only.
because now in compile time you get all the record, whatever record condition you are pushing here in DF example.
Hmm.
Okay,
Hmm.
it's already in DF example. Now you are using DF example explain.
Hmm.
Okay, but at runtime it is doing with column. Okay, after with column it is doing the explain.
Hmm.
Here it is in compile only runtime it will run this
Hmm.
one, not the above one. This
Got
is called
got it.
constant folding.
Hold.
Okay.
Hmm. Okay. Okay. Hmm.
Next is projection pruning. Here, this is common for MySQL query also. So instead of using select asterisk, okay,
Hmm.
use the column whatever you need.
Okay.
Okay. So now, suppose in your record, let's take mine example. Okay. In main table, okay, main table in the sense fact table. Okay,
Hmm.
in fact table fact there is a two type of table, one is fact, another like dimension table. Fact table is the main
Hmm.
table,
Hmm.
dimension table third. So in fact table I had 400 column. more
Okay.
than 400, 430, I guess.
Hmm.
But to calculate this one, you don't need all this column. You need only two to three column because I told you I need only date. Actually,
Hmm.
price. Everything depends on GST, that means price. Okay.
Hmm.
So I need invoice number, invoice date, that means in which month it is creating, and invoice
Hmm.
price. This thing is
Hmm.
only required. Rest of the thing, what GST number, uh, again GST number only, this four field. Okay.
Hmm. Hmm.
So when the GST registered, when this, whose name it is, I don't need that one. I need only this four value. Okay.
Hmm.
If you put star before doing any like manipulation with your data
Hmm.
frame record, what will happen? The pointer will read all the code first, all the column,
Hmm. Yes.
2000 column. Then
Hmm.
it will work on the four column. But it will
Yes.
read, no.
It will
So why
read.
you want to do that? You need four column. You will ask only four column.
Okay. Hmm.
Okay. This this is going to your Bible again. I'm telling you. I
Hmm.
already
Hmm.
explained projection pruning. Okay.
Hmm.
Now filter reordering. Okay. Filter reordering. You have to day before a day after tomorrow. You have to do that one. Sorry. Filter. Here. Okay. DF filter column edge filter then. So you have two condition here. Very simple.
Hmm.
Okay. Now if you check with, so how many 25 20, how many value you have greater than 25? So it will be your 28, 35, 40. Huh?
Hmm.
28 also.
It's okay. Hmm.
And
Hmm.
uh, suppose country is USA. Now you are
Hmm.
interchanging this condition. First you will put this condition, then you will put this condition. What will
Hmm.
happen? Suppose you're here in example, you have US value that is 1000 times, and your
Okay.
column age is greater than 5, it is only 100 times.
Hmm.
Now if you put USA first, okay, USA first means it will check the USA. It will automatically
Hmm.
first figure it out the all filter in USA. Okay, then
Hmm.
it will do the age thing.
Hmm.
Okay, so to know your code, to know your data, okay, you have to figure it out which filter you are going to use it. Okay, otherwise, Catalyst optimizer will do it for you. It will automatically reorder your filter, whatever it is required first. You are, so suppose here you change this one and send it to
Hmm.
here. So my catalyst optimizer, Spark Catalyst Automator, automatically change these things and give you the proper result. So it will not check thousand of USA. It will check only 100 of greater than 25.
Okay. Okay. Got it. Okay.
Got
Instead
it?
of so checking US.
Instead of that much of data, USA you have 1000 record, and
Hmm.
age
Hmm.
equal to greater than 5 equal to 100 record. Okay. So you don't need to read 1000 record. No, very simple.
Hmm. Hmm.
You need only 100 record. So first it will check the 100 record, then it will check with USA. In those
Uh,
100 record, how many USA you have?
but
But
like even to get that greater than 25, right? It has to go through the whole data, right?
no, because in age, okay, as I told you now, the partition. So greater than 25. So you are doing partition with using age.
Hmm.
1 to 10 record, it will create one partition. 10 to 25 will create another partition. 25 to 35 create one another partition. Okay.
Okay. Okay.
Now you understand
Hmm.
this is my partition. Okay.
Okay.
If I
Okay.
put filter country USA, it will check all the record. So you have 1000 record. It will check all the partition with 1000 record. But if you are using
Got it. Got it.
age, okay, it will
Hmm.
not check other one. It will directly focus onto that which is greater than 25, which is going to
Okay.
100. then it
Hmm.
will check the USA.
Okay,
So
okay, got
depend
it.
on your partition, these things will uh, change. Catalyst
Hmm.
optimizer will change it.
Okay, got it.
Okay. Now, uh, join reordering is there. I will not tell you because join I have to teach you. There is a lot of join. It's not my SQL type. Lot of join is there. Then I will tell you with using AQE how you can do the joins recording. Same thing, simplification. Because if I tell you, you will not understand. Okay.
Okay.
So these things is called catalyst optimizer. So
Hmm.
now think about it. Where is my image? Yeah. Now check your image.
Hmm.
After logical plan, okay. Now your catalyst optimizer active.
Hmm.
Okay. It will check all this possibility. Okay. After checking all the possibility, it will create multiple logical plans. Okay.
Hmm.
Because it is like check and trial. Okay.
Hmm.
With this setup, you are getting uh, after using USA, after getting so there is a multiple uh, permutation combination happen and it create multiple physical plan. So
Hmm.
after logical plan which is come from unreserved logical plan which only which checked by catalog, and in catalog we are storing metadata. With using metadata, unresolved plan comes to the logical plan. It is called
Hmm.
analysis phase. Okay, in
Hmm.
logical plan, now we are encountered with some set of optimizing plan like predicate push
Hmm.
down. This type of
Hmm. Hmm.
predefined optimization technique. You are going to encounter this one. If everything
Hmm.
is okay, okay, it will create a optimized logical plan. Okay,
Hmm.
after one second. Logical plan, optimized logical plan. Hmm. Hmm. And after logical plan, optimized logical plan, logical plan. Then it will come to the physical plan. Okay. Yeah. Then it is come to the physical plan. So then so physical plan, why it is, as I told you, why it is multiple physical plan? Because there is a lot of joining. One is short merge, another is a broadcast, another is shuffle hash, then a whole stage code generation. Okay, this type of multiple queries there. From there, you so for short merge join, you are getting 4 plan. For broadcast join, you are getting 5 plan. Shuffle, you are getting 3 plan. That means that many much of physical plan it is creating. Okay, now you have 30 physical plan. Now
Hmm.
you are you will face cost optimization, a cost optimization model. Okay, one second.
Sudeep, like optimized also we have multiple, right? Sorry, optimized logical. Then why again physical we have multiple?
Optimized
Hmm.
logical plan is one. Okay, so if now optimize up to optimized logical plan, you are getting 1111. Okay,
Ah,
now you are doing lot of permutation combination. Okay, so predicate push down, column pruning, all those things you are doing right now. Okay, constant
okay.
folding, projection pruning, filter merge. Okay, this type of things you are doing. After doing that, okay, multiple physical plan. Okay, for suppose today you are getting some record. Okay, and you
Hmm.
did some optimization.
Hmm.
Tomorrow you are getting more record. Okay, now your first physical plan will not die down, it will store there. Now again
Hmm.
you are creating new physical plan because every
Hmm.
single day the CICT sorry, CICT, data pipeline is changing, no, as per
Okay,
your
okay.
record.
Got
Okay,
it,
there
got
is
it.
no
Hmm.
such
Hmm.
like hard and fast rule. Okay, you create this one, it will not going to change every single day, you have to change it.
Hmm.
Okay,
Hmm.
so
Got it.
that means so you have using seven optimization plan. I
Hmm.
can tell you, you will get at least 7 into 7. Okay. That means
Hmm.
49 physical plan.
Okay. Hmm.
Now you are on the physical plans, not physical plan. Okay.
Hmm.
Now, cost model. It is called cost optimization model. Okay, what cost optimization model will do? Okay, there is a rule-based join order, CBO join order, CBO cost beneficiary broadcast join, filter sensitivity optimization, aggregation cost minimization, column tuning optimization. I will tell you, you have to write those all these things. Okay, so you after physical plan, those will come into your cost model. Okay, after using all this cost model, you are going to get one selected physical plan.
Okay.
Okay, after
Hmm.
getting one selected physical plan, okay, the code generation happened, whatever you write code. Okay,
Hmm.
after clicking on action, it is after clicking on action what happened. Okay,
Hmm.
so you did that. Okay, your physical plan finish, your code generation happened, and
Hmm.
so into RTD.
Hmm.
From
Okay.
there you can use it.
Hmm. It's
You are
fine.
you are sending a query.
Hmm.
Query will come with syntax error. You
Hmm.
will face unresolved logical plan. If there is error, it will
Hmm.
stuck your code. Otherwise, it will send it to uh, analysis phase. In analysis
Hmm.
phase, what will happen? Your query will check with catalog. Okay, what I told
Hmm.
you, what is there? Catalog store metadata. That means
Hmm.
every single outside structure of that table. Okay, if
Hmm.
the record is exist, that means table is exist. Is if column is exist. Okay, if so then you are going to create logical plan. Okay, after creating logical plan, you are doing a logical optimization by via catalyst optimizer. What are the
Hmm.
catalyst optimizer? This nothing but predicate push down. Okay, next is column pruning or projection pruning,
Hmm.
then filter reordering, then constant folding. Okay, in between you have to do like simplification and cost based optimizer also. Okay, if everything is, it will check with all possible physical plans and it will
Hmm.
get the single one selected physical plan. That selected
Hmm.
physical plan will generate the code and put the data into RTD.
Hmm. Okay. Got. Hmm.
Okay,
Hmm.
okay. Now question is how cost based model works. Okay,
Okay.
one second. So um, in cost based optimization plan, most of the case it will check the join reordering, broadcast join decision, filter selectivity optimization, aggregation cost minimization, uh, and next is this one, what it says simplified. Okay, no, join order, then broadcast join decision, filter selectivity optimization, aggregation cost minimization, and column tuning optimization. These things in cost model, it will check with all plans and getting the new plan that is selected physical plan and which is going to store into there. Any issue or you don't understand
No, I
anything?
understand. No, I understood that cost model has like too many big words. So I'll
Has
take
so
local ones.
so very simple. You are
Hmm.
sending query. Okay, you are writing query.
Hmm.
Okay, now you are firing one action.
Hmm.
What will happen inside of that action? So it will come. Look, in interview they will ask you the question about
Hmm.
this one. Okay, so
Hmm.
simple in SQL query. So let's take data frame or SQL query. Okay,
Hmm.
there First time you have your data will check the syntactical issue. Okay, if everything is that is an unresolved logical plan. If everything is
Hmm.
okay with using catalog in analysis phase, okay, it will come into logical plan. Okay, in
Hmm.
logical plan, the optimization catalyst optimizer works, and uh, it will send the physical multiple plan. Okay, uh, then cost model. Some of the cost model I already told you what they are checking in cost model. They selected only one physical plan, and that
Hmm.
one physical plan will store into uh, RDD.
Hmm. Okay.
Okay.
Hmm.
Next point. Next point. You already said that one, no? The list.
I sent it. Yeah.
SQL Catalyst Optimizer, uh, RDD, job, stage, task. Okay. RDD means resilient distributed database. Okay. RDD is the most basic structure of Apache Spark. It is fault tolerant, distributed, immutable, the collection of record. Okay, first I have to tell what is RDD. So what is the meaning of R, what is the meaning of D, and what is the meaning of D?
Hmm.
First is resilient. Okay, that means fault tolerant.
Hmm.
If you like lost any data in RDD, there is a concept that is called lineage. Using this lineage, you will again get those data. So in RDD, it is very difficult to lost your data. Okay, you
Okay.
can easily retrieve with
Hmm.
using lineage,
Hmm.
RDD lineage. Okay, this is the first point.
Hmm.
Next, so what is RDD? That means in cluster, no one can able to delete the data because
Hmm.
it is stored
Okay.
into
Hmm.
lineage. Okay, now Arts
Hmm.
first D, that is distributed. Okay,
Hmm.
so as I told you, either RDD or data frames, okay, it cannot be stored into one place. Okay,
Hmm.
so when your request is come will come, okay, it will distribute it into different portion, and different
Hmm.
portion do their processing. Okay, in
Hmm.
everywhere the RDD is creating. Okay, so what I'm trying to telling you, RDD cannot stay in one place. So it stayed in every cluster. Okay, every cluster executor area. Okay,
So like we have multiple executors, right? So like
yes.
the location changes every
No,
time. Like,
every executor gives you one RDD.
acha,
You
every
request
ex.
one thing, yeah, every this one will give you one RDD.
Acha, okay.
RDD means that is the platform where your processing data, process data will display. Simple.
Hmm.
Okay. Yes, RDD is the platform where you cannot able to delete your record because there is a option called lineage, which is not in
Hmm.
data frame, which is not in data set, only RDD. Okay.
Okay. Hmm.
So in RDD, you will get the data.
Hmm.
This is for a reason. Still, lot of company you without using this one. What it say? Mm,
Data frame.
data set or a data frame, they are using
Hmm.
RDD because they can use the lineage. Okay. Yeah, if you use data frame, you also can use that data frame, but not directly. Then you
Hmm.
have to switch your all the data into RDD. From there, you can search it. Okay. So better using RDD here only. Okay. Next point is data set. So it is data set obviously. As I told you, data set you
mm,
have to store it, you have to present in RDD only by using
okay,
executor.
okay.
Okay.
Uh,
What is the key features of the RDD? Key features of the RDD is nothing but it is immutable. Okay. If you wrote one RDD, you cannot delete it.
okay,
If you do the transformation on the RDD, it will create a new memory. Okay.
okay.
But it will not change the old one.
Mm,
Lazy evaluation, that means after
mm,
all transaction, the action will happen.
mm,
Okay. Partition. So partition means from RDD, they are instructing, okay, with this type of data, that should be the partition key. The partition will happen with this particular area. Okay. So that partition, that is also because partition is obviously doing the parallel processing. So it's not like one partition will work at a time.
mm,
So that is why that is required. Uh, Partition. Fault
mm,
tolerance, as I told you, fault tolerance, it will never happen because the
mm,
lineage concept. Use the
mm,
lineage concept, you will get all the record again. Okay.
mm,
And RDD, why we are using Spark? Because it is the in memory computation. Instead of storage, we are doing in memory. Okay.
mm,
And RDD is the responsible person to do that. Okay.
mm.
Thus, RDD of a Spark is the responsible for to do that. Uh, Theory part, I'm not going to tell you. But I should take the so yeah, leave it. Leave it. This is RDD. Okay. A directed acyclic graph is the Apache Spark represent the sequence of operation, transformation, and action. I am telling you what is DAG. DAG means, think about it. This is the DAG. This whole area, this square area is the DAG, where all your think about it like that. A directed acyclic graph, a DAG. This is the
Mm,
full form. Okay, DAG is not only for Spark. DAG you can use in Snowflake. DAG you can use in lot of place because
mm.
after using DAG concept, lot of things getting so easier.
Okay.
So DAG is the Apache Spark represent the sequence of operation. You are doing
Mm,
creating something, you are doing transformation, you are doing action. Okay. This operation, transformation, action that Spark will execute on a resilient RDD or data frame. It is
mm.
visual blueprint of the computation outline and dependency between operation, how data follow through them. Okay. DAG in theory part, I will tell you because whenever you do something, no, any operation, a graph
Mm,
will create, automatically a graph will create. Okay, this is called nothing but DAG. So with you
mm,
checking that graph, you can understand, okay, here you did a transformation like filter, here you did a transformation like group by. With that
mm,
graph, you can if, actually for us, we don't have time to check all the code. Okay, what we are
mm,
doing,
mm.
we are using DAG, we are checking the whole design, whole graphics, and we are
Okay,
understanding.
okay.
Okay, this type of things
Mm,
you did.
mm,
Okay, then
okay.
so this is the DAG where you are getting a visualization.
Mm,
Okay, oh, it's already stopped. Okay, tomorrow I will show you. Tomorrow I will show you
mm,
with data breaks. Okay, so
mm,
whenever you create any transformation or any actions, okay, not in transformation. When you do that action, at that time the DAG will create that
mm,
graphical thing will create. Okay,
mm.
by which you understand. Okay, this is what is it, and DAG is important because for optimization
Okay.
because
Mm,
any transaction, how much time it is taking. Think about a balloon. Okay.
mm,
So in balloon, there is a like that chamber, that air chamber. Okay.
Hmm.
After that, this small area where people can sit there. Okay. Balloon means I'm talking about if you can sit that balloon, no, this type of
Actually,
it,
that hot air one. Actually.
hotter one. Yeah.
Ha, ha, okay, okay.
So the above one is the big one.
Hmm.
Okay. So you are putting uh, now why it is big one? Each which transformation it is creating the big volume. Okay.
Hmm. Hmm.
So you can after checking the graph you can understand
Okay. It shows the flow, like
all
easier to
flow and
understand.
how it
Okay.
takes, why it takes time. Okay, how it
Hmm.
takes time, how much time it takes, every single thing designed there.
Oh, okay.
And it not like that at the end it will create. No,
Hmm. Hmm.
while processing it will going to create. So you after submitting something or
Hmm.
submitting any action, you can open the
Hmm.
DAG and you can see how it is going on. This is how
Okay.
you have to like when someone will test. No, this is that much time it is taking. How
Hmm.
you will
Hmm.
understand? Then you have to open your DAG and you have to sit before that. Okay, okay, this transformation is taking time. Then you have to figure it out which cost optimization technique I will use to reduce
Hmm.
that this one.
Hmm. Got it. Hmm.
Okay, this is the DAG. Databricks DAG image. Let's see images. Look, look. This is the images. Arey, yeah, yeah. Look, executor
Sure.
5 added, executor 7 added, executor
Hmm.
6 added. When it is added, collect at 33 job. Job 2, 33 stage. Okay. Job 0, 31 stage. Job 1, 34 stage. Why it is that much? Executor 6 removed. Now it will tell you, okay, why it is removed.
Okay. Hmm.
All these details of job. Okay.
Hmm. Hmm.
Now it is mapped into 24 stage 8.0 details so every single thing look this task is taking so you have four tasks this task
Hmm.
is
Hmm.
taking this much of time this one that much of time why it is taking that much of time then you have to figure it out okay this is taking time why it is taking time okay look every single thing it is success it will take every single thing scheduler delay 60 seconds this is how you have to this is how you need to know how it is like if you don't have any graph if you don't have anything okay nowadays
Hmm.
it is very difficult with using code you cannot do anything there
Hmm.
should
Hmm.
be there now
Correct.
which you can
Hmm.
understand DAG is that form and in every language what wherever that is why DAG introduced in 2000 of 14 I guess yes before
Okay.
that
Hmm.
Apache was there DAG was not there in Apache
Hmm.
1.0 DAG was not there DAG introduced in Apache Spark 2.0
Hmm. Okay.
from
Hmm.
2000 of 14 it started. Got my point?
Hmm. Yes.
And tomorrow I will show you every single
Hmm.
thing.
Hmm.
uh, that balloon one look each and executor.
Hmm. Hmm. Sure.
Yeah. Hmm. Orchestration tool extract when you are extracting data
Hmm.
CSV now you are doing raw CSV load
Hmm.
invert table creation SQL free data every single thing you can understand here in DAG from starting to ending
Hmm.
you
Got
can
it.
you can easily rectify your code that is why
Hmm.
we are using Spark no
So,
then
okay.
for
Hmm.
this reason we are using Spark
So it tells you if any particular part is very slow. Then you
every
go and
single thing
fix.
not only slow even fast also you can
Hmm.
tell
Acha, okay. Hmm.
fast also you can tell no
Hmm. Hmm. Hmm.
hmm. Look this is the text file means
Hmm.
CSV file whatever file it is okay
Hmm.
Arey, ye, how can I remove this one Mm,
Mm,
I need to remove this one.
click on, there is a cross icon coming, right?
No, it's not coming.
We care for your privacy.
Mm. So
Mm,
transformation function in Scala Spark. Okay. Map function filter. Look, flat map. Now think about it. Flat map.
so okay.
So you're starting from here, stage zero. Okay.
Mm,
Then you come to flat map. You are using flat map here.
mm,
Okay. Then you are using map here.
mm,
Okay. After that, you reduce by key. Data is
mm,
shuffled here. Now you are doing reduce by key. Here it is reduced by key. Okay. So whatever this is like lineage, whatever you are doing, all will
mm,
reflect in your DAG.
mm,
You can easily understand from there rest of the thing.
mm,
Okay. So this
mm.
is DAG. Uh, okay. Tell me any issue today. Yes, obviously today you have to read it again, but till now, because today's thing is very important, as I told you.
No, no, theory things I got like
Okay.
last.
One more day I will take
Mm,
job stage task and
mm,
memory execution. Okay.
mm,
Rest of the thing, first half will be theoretical, practical part, half
mm.
part will be the theoretical part. Because
Okay.
theory, you need to know partition, okay,
So,
bucketing, salting, uh, ha, only this one. Oh, join. There's a five type of different type of join that you need to know. But that's all theory part. Also, this is the practical part also. You will learn and you have to do instead. Okay. So this jar file, a Spark submit, you have to write Spark submit. Okay.
mm,
This is the code. You are creating a Spark object. Okay. Your JDBC host name, JDBC port, database, username, password, table, URL. Okay. Then
mm,
spark.read, you are reading this one and you are writing this one. Okay.
mm,
So this type of things.
mm,
You
mm,
have to read from S3 bucket. Okay.
mm,
I will
mm,
tell you 10 or 12 transformation. Okay.
mm.
You have to, because look, optimization you cannot do right now because you need a
Correct,
cluster.
correct.
Cluster,
Mm, mm.
it's not possible now. So then if you have 20, 30 laptop, then I can set up for you. But I think you have
No,
only
at
one
least,
laptop.
yeah, yeah, basic,
Yeah.
yeah, at least basic I need to learn first thing.
And
Mm,
optimization, you can only reading will not help you. Optimization is totally experience.
mm, mm,
Okay. You can see DAG things. Okay. This is the DAG
mm,
things you can see, but you cannot do right now. You
mm.
you need experience for that. You need
Correct.
DevOps experience. You need a lot of experience you need. Then only you can do that. So
Mm,
like
mm,
you have to do some transformation. Okay. Then you have to write JDBC, MySQL. Sometime I will tell you, okay, write it in Redshift. Okay, Redshift
mm,
means a warehouse. Sometime I
mm,
will say write it in Snowflake.
mm,
Okay, this type of things. That means uh, demo production thing I will tell you.
mm. Okay.
Okay,
Mm,
uh, and when you write this type of code, you will look. There is, I'm telling you, 95%. Okay, 95% PySpark and Scala code is same.
mm, mm,
In Spark, everything is there. We don't need to write val. Rest of the thing is same.
mm,
Because in Spark, PySpark, that is in Python, we don't need any variable value. Okay.
mm,
Rest
yes.
of the thing is same. Same
Mm,
format here. Okay. Here you have to stop your Spark code. In Python, automatically it stop.
Okay, got it. Mm,
Okay. So this type of things, you have to do. Okay. Huh. So production level thing you have to do actually. Last 2 week consecutive week you have to work on it
Got it.
in front of
Actually,
you.
Sudeep, I was going through some of the existing codes, okay, that these
Hmm.
guys have in my project.
Hmm.
I'm not able to figure out like there are so many Scala codes in so many folders. So, like later stage, can we
No,
have
first,
some?
first, first tell them, ask them which
Uh,
framework they are using. We have to install that framework. Look, play format there. If it is a microservice basis, then Akka framework there's there. Okay, and Apache Spark itself a framework, Lift framework is there, Legume framework is there. So which framework? I think it is either Play framework or Spark framework.
Acha, okay.
Okay,
Hmm.
this type of very important is Play for framework.
Hmm.
So that you have to check. So framework had its own structure. If you want to see any framework file folder system, no, you will confused. So don't think about it.
Mm-hmm.
Your
Got no
focus.
later stage I'll
Ha,
because Java and Python I understand there is a single execution file like
ha,
one entry point or something. Here
ha.
like I didn't understand the
No, no,
structure
no, no,
because
no. In Python also, if you use
mm,
Django framework, okay, there's a multiple
mm,
entries there.
acha, okay, acha then okay. Acha
It's okay, no,
later
no, not a
not
big
a
deal.
issue. Yeah,
When
yeah.
let it finish, then we will
Ha
go
ha.
with it. Okay? Okay,
Sure,
I
Sudeep.
receive your thing. Okay?
Got it. Yeah,
Yeah.
sure, Sudeep.
Okay.
Yeah. Thank you,
Chalo.
Sudeep.
Bye.
Yeah. Good night. Yeah.